Okay, I know, one problem. It's stressful. Here we go. We're going to talk about the difference again of rate of change versus instantaneous rate of change. We touched on this way back on literally day one before you knew anything about derivatives. The rate of change is like the average rate of change. It is literally the slope that you've been doing since the 7th grade. The instantaneous rate of change is the derivative at a specific value. It is the rate of change at an instant. Okay, so I have this function. It is quadratic. Be the number of gallons of water in a cistern T minutes after an outlet pipe is opened. Find the average rate of draining during the first 5 minutes and the rate at which the water is running out at the end of 5 minutes. Okay, let's make sure we understand the question. This part is this. The rate at which the water is running out at the end of 5 minutes. Now, don't let at the end of 5 minutes make you think it's the total accumulation. It's just saying when 5 minutes is over, what at that time is the rate at which the water is running out. It does not say how much water has run out or ran out or been dumped out. It's saying at what rate is it coming out at minute 5. Okay? So the yellow, the average rate of change from t equals 0 to t equals 5. So first I need to find g of 0. 15 minus 0 is 15, so this is going to be 400 times 15 squared, which is 90,000. And now I need to find g of 5. 15 minus 5 is 10. 10 squared is 100. 1, 2, 3, 4. So now I can do y minus y over x minus x. So 90,000 minus 40,000 over 0 minus 5. I have to have the 0 first because that goes with the 90,000. So 90,000 minus 40,000 is 50,000. 0 minus 5 is a negative 5. So that gives me a negative 10,000. Now, negative 10,000 what? Well, this is the rate at which water, the average rate of change of the drainage of the water. And we are in gallons of water in minutes. So we are negative 10,000 gallons per minute. Now, I know you think that units of measurement are not important, but on an FRQ, most times, just the units of measurement get you an entire point. So you could have totally screwed up your 10,000, lost your negative, done it completely wrong. But if you have the correct units of measurement, you are showing an understanding about what you're finding, even though you found it incorrectly. Maybe you made a little algebra mistake. You can still get a point for your units of measurement. That is your A rock. It is important that you show that it is negative because that's telling you that your slope is going downhill, decreasing. All right, now I'm going to find my I rock, which you could not find until you learn derivatives. So guys, what I'm looking for, now this function is called g, so I'm looking for g prime at 5. I'm looking for the instantaneous rate of change at 5 minutes. I'm not going to write that twice in lobster it. I'm going to turd duck in that sucker. So bring the 2 down. And then I've got a duck. There we go. So negative 800, 15 minus t. Now I want at 5. So negative 815 minus 5 is a 10. Negative 8,000 gallons per minute. At exactly 5 minutes, the rate at which the water is running out is negative 8,000 gallons per minute. Big difference from the negative 10,000 gallons per minute. So that shows you that it is slowing down because the average rate of change over the first 5 minutes is 10,000 gallons per minute, but at 5 minutes, we're at 8,000 gallons per minute. So the rate at which it is draining is slowing down. And that's it. That's all this is about, just to reiterate the difference between average rate of change and instantaneous rate of change.